This is part 8 of the 2008 final, section A. Um, Here we're finding the pure Nash equilibrium when the students have these thresholds. So I have it written out here. When student A has a threshold of 1, B and C thresholds of 2, D and E thresholds of 4, F and G thresholds of 6. So being that there's not a student that has a threshold of 0, no one will spontaneously decide to go. So you can see that here where in the initial state, no one decides to go. This means that no one will continue going forever. So that would be one pure Nash equilibrium. Um, in this case here, everyone will decide to go if in the initial state everyone decides to go. So everyone will continue going if in the initial state everyone goes. In this instance here, if we have students A, B, and C go, then they will continue going forever. That is because here you can see that A has a threshold of 1, B has a threshold of 2, and C has a threshold of 2. So all of these students' thresholds are filled, whereas D, E, F, and G, their thresholds are not filled by this specific scenario, so they will never go. In this last instance here, if students A, B, C, D, and E decide to go, then they will continue going forever. However, students F and G will never go because, again, their threshold of 6 has not been filled. So if you look here, I've written out the Nash equilibrium, where the only way to have a pure Nash equilibrium is either no one decides to go, so no one ever goes. Everyone decides to go, so everyone goes. Students A, B, and C decide to go, and they continue going forever. And students D, E, F, and G decide not to go, and they decide not to go forever because of their threshold. And then lastly, we have students A, B, C, D, and E go, and they continue going forever. And then F and G never go. So you can see here that really it just depends on the initial state in order for the pure Nash equilibrium of this specific scenario with these thresholds. If we come down here to section B, you can see that student A now has a threshold of 0. You can also see that B and C have a threshold of 1, D and E have a threshold of 3, F and G have a threshold of 5. Also, now, which was different than in section A, there's an upper threshold. So student A will stop going if one or more person starts going to the review session. Students B and C will stop going if 2 or more people begin going to the review session. D and E will stop going if more than 5 people show up to the review session. And then F and G do not have an upper threshold. So if we look here in the initial state and say that no one goes, then because A has a threshold of 0, they will go the second time and no one else will go. And the third time, A will continue going. However, this time, because there was one person in the previous section, the one person fills the lower threshold of person B and C. So then person B and C decide to go. In the next instance, though, person 1 decides not to go because their upper threshold was passed. Similarly, persons B and C decide not to go because, again, their upper threshold was passed. Their upper threshold was 2 and there was 3 people. However, persons D and E do decide to go because the 3 was their lower threshold. And then again, in here, persons F and G decide not to go. In the next instance, because there were two people and not more, then persons B and C decide to go, and then they essentially keep going forever because their threshold, their upper threshold, is never passed because it does not meet the requirements of person A or meet the requirements of persons D, E, F, and G. So you can tell by this that the pure Nash equilibrium is that person 1 will never go, persons B and C will always go, persons D, E, F, and G will also never go. And basically that's written out over here, where these two people will always go, never go, and never go.